Okay, sorry. So as you're going through these charts for these projectiles problems, I wouldn't so much, as you're making corrections on your sheet, I wouldn't so much worry about correcting each and every number as much as understanding the process. All right, each column of that table involves a rule or a concept. And if you understand that rule or concept, you should be in good shape. Okay? So here's what I think I want to do. I'm going to go over number 3, which is the one about the football being kicked at a weird angle. Okay? Because I think of the two, that's the harder one. And if you can do that, number 2 is just a very special case. And you'll look at it and you'll be like, oh, it's the same thing except something, which we'll talk about. Okay? So, in number 3, what's happening is the football is being kicked, and the problem tells you that it's being kicked at 40.405 meters a second at an angle of 76 degrees above the horizontal. Okay? Oh, and as a quick, well, I'm ahead of myself. All right, remind me that there's one tiny mistake on the answers. It's nothing big. Okay, so everybody good with this? So what that means is the instant that the football becomes a projectile, that's the velocity. Okay, so I'm standing there with a stopwatch and I'm waiting for the football to leave the dude's foot. And the instant it leaves his foot, I click start. Okay, at that instant, it is already moving. All right, your velocities do not start at 0. All right, the only way that your velocity would start at 0 is if you were dropping the object. Okay, because then my horizontal and vertical velocities are 0, my initial velocity is 0, it's not moving. Okay, but as soon as it's being thrown with any sort of initial velocity, then your starting velocity is not 0. Good with that? All right, so what you ought to do is the same thing you would do if you had a force at a weird angle, which is draw the vector. So here's the velocity vector for my football. My initial velocity is 40.405 meters a second. Oh, it's being kicked at 76 degrees above the horizontal. What's the first thing you would do if this was a force vector? Split it up into components. Do the same thing, right? The video gave you rules about horizontal velocity and vertical velocity, but nothing about weird, stupid, slanty velocity. Okay? There aren't rules for the velocity itself, just for the components. Okay? So draw on your triangle. Here's your VIX. Here's your VIY. Okay, so notice, this is VI. So this is VIX, as in the x component of my initial velocity. And this is VIY, as in the y component of my initial velocity. Follow? Do you guys agree that I can just do some simple trig and figure those things out? Cool. So if you do that, this one turns out to be 39.2 meters a second. And if you do this, this one turns out to be 9.77 meters a second, which is unfortunately and totally by coincidence very close to 9.8. But that is just arbitrary chance that that happened. Okay, don't make any generalizations from that, because that won't usually happen. All right, are we good? All right, so what this means, you guys, is at the instant the thing becomes a projectile, it is moving horizontally at 9.77 meters a second, and it is moving vertically at 39.2 meters a second. Follow? So what the chart asked you to do then was take this information and find out a whole bunch of other garbage about the motion of the projectile. So are there any questions on what this means before I take this information and plug it into the chart? Okay, so here we go. So the chart has time, 0, 1, 2, 3, 4, 5, 6, 7, 8, sorry. First column is Vx. So V is a measure of velocity, x means horizontal. So what is the x component of my starting velocity, you guys? 9.77, right? Now, in the video, hopefully you learned the 2 big rules. And the first big rule told us something about the horizontal motion of a projectile. Constant, right? How fast the projectile moves that way does not change. So that means that these are all just 9.77. Follow? Any problems with it? Okay. And everybody's cool that the 9.77 just came from here? Okay. Vy column. Well, at the instant my one other quick comment, but before we go to Vy. Vx. This is probably the only time this class I will ever write Vix. I'll usually just write Vx. Why? As in how come, not y as in why. Yeah, the Vx is constant. So do I need to say initial? No, I could say initial, I could say final, I could say average. They're all the same because it's constant. Cool? Everybody happy? Okay, cool. So that's the Vx column. Vy begins at 39.2. Now, the Vy column is not constant. Why not? How come the Vy changes? Tim, what do you got?
Because you have the force of gravity pulling down 9.8 meters per second.
Oh, you're super close. You have the force of gravity pulling down, causing it to accelerate at negative 9.8. You guys understand that distinction? It's not the force of gravity that's 9.8, it's the acceleration of gravity that's negative 9.8. Okay, but yes, at the heart of what you had the right idea, just raw words. Everybody good? So how do I fill in this column, you guys? Just keep subtracting 9.8, right? So you get 29.4, 19.6, 9.8, 0. Why is that point important? That's when your vertical velocity is 0. So vertically, you've stopped moving at the top of the path, right? Isn't that when you stop moving up? And you begin to come down. So what should happen to my Vy's? They should now be negative. So this point here is important because it is the top. Cool? Trick question. Well, not trick question, but commonly missed question. What's the velocity at the top? Good. Vertically, the velocity at the top is 0, but it's still moving horizontally at 9.77. Right? If you picture firing an arrow, when the arrow gets to the top of the path, isn't it still moving this way? At, in this case, 9.77 meters a second. Okay? So that's what this next column is. The next column is the V column. It's the overall velocity. It's how fast the thing is actually going. All right? We know 3 of them without doing any math. This first one, what was the starting velocity? 40.405, right? Oh, well, that means this last one should also be 40.405, right? Because I've got the same Vx and the same Vy, right? Make sense? And at the top, it's 9.77, right? How do I fill in the missing ones? It's a little tedious, but easy. That's the next column you're on, Abby. Brianna, you got an idea? Square the columns and then add them, and it's Pythagorean theorem, right? So arbitrarily, if you wanted to do, say, 2 seconds, here's what you'd do. I mean, you don't have to write it all out, but basically what you're doing is you're saying, all right, well, let's see. I'm moving horizontally at 9.77 meters a second. I'm moving vertically at 19.6 meters a second. So my overall velocity is v. So yeah, just do Pythagorean theorem. That's this whole column. So Pythagorean theorem. Good? Please be careful when you do the Pythagorean theorem. What is 3 squared? What is negative 3 squared? Ha ha ha! It depends on what you mean. If you type this into your calculator, it will give you negative 9, which is not what we want. Because your calculator will follow order of operations. And it will do excuse, the exponents, before it will do the dear Aunt Sally, the minus. So it'll do 3 squared and then make it negative. Is that what we want? No, what we really want is negative 3 squared. So when you do the Pythagorean theorem, if there are negatives, make sure you put the negative thing in parentheses and the squared outside of the parentheses. Or know it's going to be positive anyway? Cool? Everybody happy? Did I say or loud enough? Did everybody hear it? All right. I was going to say one other quick thing about the Pythagorean theorem. Oh, I know. Should I make these ones negative because it's coming down now? Nuh-uh. Big important question that I did not put on your thing, but I did put on my answer key. Why can't I just make these negative? This is a super important concept-y thing that you should understand. Thoughts about why I can't just make it negative? Coming down, it should be negative, right? No. Why? Got any others?
Well, it's the hypotenuse. It's not either the x or the y.
Okay, so why is it not the x or the y important?
Well, because with the x and the y, you have your directions attached to them. So the left is negative, the right is positive, or the top is positive, and the down is negative. But at the hypotenuse, you aren't going straight up and down or side to it. So it's just going to be positive.
Good. Yeah, those positive-negative conventions only apply to x-axis or y-axis. Right? If I tell you that I drove -2 miles to work today, or sorry, -2 miles to work today, do I mean -2 this way, or that way, or what does the -2 mean? I don't know. So how do we describe this direction? We can't just say negative. What do we have to do?
Say direction.
Say direction. How do you do it? So direction. No, I'm being an asshole. How do you do it? Oh, so there it is. What do you do? Get the angle. And then you say so many degrees, either above or below the horizontal, right? So that's the column that I added into your answer key. Cool? There are 2 mistakes, though. I kind of got on autopilot. So, see where it says horizontal on one of them? The next 2 should both be below the horizontal, and they say above the horizontal. Does everybody see that? There's one right in the middle. After 4 seconds, it says the direction is horizontal. Right? Because at the top, the path is horizontal. And after that, everything should be below the horizontal. And for 2 of them, I wrote above by accident. Okay. Any questions on all this velocity business? Everybody happy? Anybody unhappy? Anybody confused, confuzzled, bamboozled? Anything? Right? You good? You sure? Okay. You look uncertain.
I'm good, yeah.
Okay. I'll let you off the hook then. All right, cool. So everybody's good. All right. So next, Abby, I'm going to pick on you for a second. Delta x. How am I? Well, so first of all, what does delta x mean? How is delta x different from vx? Good. It's the horizontal distance. Vx is how fast you move horizontally. Delta x is how far you move horizontally. Good? So Abby, what do you got? How are we going to find those guys?
So that would be the horizontal velocity times the amount of time.
Yeah, look, we're moving 9.7 meters a second every second. That was the worst sentence ever. Every second, we're going horizontally 9.7 meters, right? 9.77. Good? So for every second, I'm going to go 9.77 meters. So you start at 0, and then either just keep adding 9.77 for every second that goes by, or you just do 9.77 times however much time has gone by. Cool? Problems? All right. And then finally, the delta, is that enough? Did I say enough about that one? So the delta y column is the one I'm guessing messed the most people up. Yes? Okay. So in order to find out information about the delta y column, you only use information from the vy column. In other words, it's the vertical velocity that determines the vertical displacement. Okay? Does that make sense? All right. So hypothetically, let's suppose that I wanted to find the vertical displacement after 2 seconds. Okay? And there's nothing magic about 2 seconds. If you can do one of them, you can do any of them. But so here's how you would do 2 seconds. All right? Let's start by writing down what we know about those 2 seconds. Well, obviously, I know the time is 2 seconds. Now I want to focus specifically on the vertical motion. Okay, so automatically I know my vertical acceleration is negative 9.8 meters a second squared, right? Which tells me that my vertical velocity is changing. So I should now be thinking about, all right, well, what did my vertical velocity begin at? So what did it begin at? What did my vertical velocity begin at? Right? And at the end of those 2 seconds, what did my vertical velocity end at? At the end of 2 seconds, it's 19.6, right? Because that's what the vertical velocity is after 2 seconds. So that is my given information for those 2 seconds. Now, you don't have to write all of this out, but these are the numbers we're going to use to solve the problem. So are there any problems, issues, concerns, or anything with how I got these numbers here? Are we good? Can I smallify? Everybody got these numbers written down? Okay, so now to solve it, well, we need to find an equation that allows us to find displacement while a thing is accelerating. So first chapter we learned these. There's 3 equations. There's this guy. There's this guy. And there's this guy. Good? So basically, your delta x becomes delta y, which is the thing we're looking for. Your a becomes ay, vi becomes viy, and vf becomes vfy. So these are the equations as they are on your sheet. In practice, the way you're going to use them is this. You're going to rewrite them. Delta x becomes delta y. This is 1/2 ay times t squared plus viy times t. This one becomes 1/2 vfy plus viy times t. And this becomes 2a delta y equals vfy squared minus viy squared. And then just pick one of the 3 equations and use it and find your displacement. The hard part is not plugging the numbers into the equation. The hard part is figuring out your given information. Make this a little bigger. Uh-oh. Nope. I'm going to stop making that weird noise. All right. Does that make sense? Questions, you guys? Are we good? All right, so 2 quick last things, and then I'm going to shut up, and I'll see you tomorrow. Thing 1. Question 2 is almost the exact same as question number 3, except instead of it being about a football being kicked up at some weird angle, it's about a ball being thrown horizontally. So for number 1, you don't need this triangle. Because in number 1, your ball is being thrown this way at 14 meters a second. So that 14 meters a second is both your Vx and your, it's not your Vy, because you're not throwing vertically, you're just throwing horizontally. It's your Vx and your Vi, right? Isn't that the initial velocity of the projectile? So then what's your Viy? 0, right? Because it's being launched horizontally. Make sense or no? Questiones. All right, thing 2 I'll say tomorrow, because you guys are going to melt if I talk anymore. No, you should keep that. And, yes. I'm going to talk about that tomorrow. But here's the deal with it. Do you remember in the video, there's the plane flying and dropping the bombs? And the bombs were always below the plane? This is the exact same thing, except instead of us dropping the bombs, we're throwing the bombs up in the air. So you've got a thing that's moving horizontally at a constant velocity. It's a train instead of an airplane. Right? Okay. So if I'm moving horizontally, when I throw spit up into the air, am I doing anything to stop its forward motion? So it's going to keep moving horizontally. Me throwing it, the only thing it does is make it go up. So the spit is going to go up and straight back down because it's moving horizontally at the same rate as rowing the train.
So when it says no air resistance, is that why it's not going that way?
Yeah, so in the real world, what would happen is the air resistance would slow it down.
That's what I was confused. I was like, would it go that way and not?
Yeah, so what that actually does is it still moves this way, but just not as quickly as the train and row. Does that make sense?
Yeah.
Hey! Cool, thanks. You think you're good with it? Feeling better today? A little bit? I got you, no worries. I didn't give you your target check back then, did I? I recorded my whole discussion about it. I'm going to post it on my website at the end of the day. So it might not be a bad idea to listen to it, particularly for the discussion of number 3. This one you actually did right, except you just forgot to square your velocity and stuff. Cool? No big deal. Oh, I'm still talking! Hello, if you're still watching my dumb video.